The volcano that could erupt without warning. Some of the world's most stunning mountains are also its most dangerous. We look at them as symbols of permanence, majestic peaks scraping the sky. But beneath that serene beauty, a terrifying power can lie in wait. A power so immense it can rewrite the landscape in minutes. A force that, in some cases, can be unleashed with almost no warning at all. It was a perfect autumn Saturday on Mount Ontake, Japan's second highest volcano. The sky was brilliant blue, the air was crisp, and hundreds of hikers were on the trails, soaking in the spectacular fall colors. They were climbing a mountain considered relatively safe, a popular spot for families and beginners. But just before noon, the mountain shattered the peace. Without warning, a catastrophic explosion tore the summit apart. A dense gray cloud of ash and gas billowed thousands of meters into the air, turning a vibrant day into an apocalyptic twilight. For the hundreds of people on its slopes, the beautiful mountain had instantly become a deadly trap. How can a volcano, monitored by some of the best technology in the world, erupt with such sudden, devastating fury? And could it happen again? We'll uncover the chilling science behind these silent killers, using the tragic eruption of Mount Ontake as our guide. On September 27, 2014, Mount Ontake unleashed what's known as a Phreatic eruption. This wasn't your classic eruption with flowing rivers of lava. Instead, the volcano acted like a giant pressure cooker. An explosion of superheated steam, gas, and shattered rock created a pyroclastic flow, a fast-moving lethal current of hot gas and volcanic debris, which surged down the mountain at incredible speed. Survivors' videos capture the sheer terror of the moment. A clear day turns to blackness in seconds. The joyful sounds of hiking are replaced by the horrifying roar of the eruption and the frantic shouts of people running for their lives. They were caught completely off guard. There were no major earthquakes, no evacuations, no alarms. 1 minute they were taking photos near the top. The next they were scrambling for shelter as rocks hailed down and a suffocating blanket of ash enveloped everything. The eruption was brutally effective. It claimed the lives of 63 people, making it Japan's deadliest volcanic disaster in nearly a century. Many of the victims were found near the summit, their hike cut short in the most violent way imaginable. The search and rescue mission was perilous, as crews had to navigate thick layers of ash and hazardous volcanic gases, a stark reminder of the mountain's ongoing threat. The tragedy of Mount Ontake left the world with a terrifying question. In an age of advanced science, how did this happen? The answer lies deep within the volcano itself, in a process that is incredibly difficult to predict. To understand what makes a volcano like Ontake so dangerous, you have to forget the classic image of a mountain slowly filling with magma. The 2014 event was a Phreatic eruption, and its trigger isn't molten rock but water. Imagine a complex plumbing system deep underground. Over time, groundwater seeps through cracks in the rock, getting closer to the volcano's heat source. This water is heated to extreme temperatures, but it's held under immense pressure by the rock above it, keeping it in a liquid state. It becomes superheated water. The danger comes when that pressure is suddenly released. Scientific analysis after the Ontake eruption suggests that a crack formed beneath the summit, causing an abrupt drop in pressure. When that happened, the superheated groundwater instantly flashed into steam. The power of this transformation is hard to comprehend. When water becomes steam, it expands to over 1,700 times its original volume. Triggered underground, this creates a catastrophic explosion. The force shatters the surrounding rock, blasting it into tiny particles and launching a dense plume of ash, steam, and pulverized rock into the atmosphere. That's a Phreatic eruption, a steam-driven explosion, not a magma-driven one, and that's what makes them silent killers. Traditional eruptions are often preceded by clear warning signs. As magma moves, it can generate swarms of earthquakes, cause the ground to swell, and release specific gases like sulfur dioxide. But with a Phreatic eruption, there's no rising magma. The fuel, the superheated water, is already in place. It can sit there for years, a hidden reservoir of explosive potential. The only trigger needed is a sudden change in the underground plumbing, like a new crack. The Japan Meteorological Agency, one of the world's most sophisticated volcanic monitoring bodies, kept a close watch on Mount Ontake. So why didn't the alarm sound? Because the mountain barely gave a hint of what was coming. In the days and weeks before the eruption, there were no major seismic swarms. There was no dramatic ground swelling. It was only about 7 minutes before the explosion that monitoring equipment detected tiny seismic tremors and a subtle tilt in the ground. But the signals were so small and so close to the event itself, there was no time to issue a warning. For scientists, it's like trying to predict when a faulty boiler will explode. You might know there's a potential problem, but you can't see the microscopic cracks forming under the pressure until it's too late. The eruption of Mount Ontake was a tragic lesson in the limits of our technology. However, scientists are racing to close this gap. Researchers are exploring new techniques like using artificial intelligence to detect faint seismic patterns that humans might miss. They are also designing integrated monitoring programs that combine multiple datasets, which could be the key to one day forecasting these events. But for now, the threat of a sudden Phreatic eruption remains one of volcanology's toughest challenges. The frightening truth is that Mount Ontake isn't unique. Many of the world's volcanoes have active hydrothermal systems, meaning they have the key ingredients for a Phreatic eruption, a heat source, and groundwater. The 2022 eruption of the Hunga Tonga Hunga Ha'apai underwater volcano was another stark reminder of how explosively these events can happen, sending shockwaves around the planet. While its mechanism was different, it underscored the same point. Earth's volcanic systems can still catch us completely by surprise. This raises an unsettling question. How many other beautiful mountains, the ones we see as peaceful or dormant, are quietly building pressure for a sudden steam-driven explosion? Mount Ontake actually had a smaller Phreatic eruption back in 1979, a warning shot that, in hindsight, pointed to the volcano's specific brand of danger. Geologists now know that Ontake has a history of these kinds of eruptions. Identifying which volcanoes have the highest risk of a sudden Phreatic event is a major focus of modern volcanology. It involves studying a volcano's history, analyzing its internal plumbing, and monitoring for the incredibly subtle clues it might offer. It remains a daunting task. The story of Mount Ontake is a humbling reminder of our relationship with the natural world. It shows us that even in an age of incredible technology, we are still subject to the immense and unpredictable power of our own planet. The same forces that build breathtaking mountains can also unleash unimaginable destruction with a speed that defies our ability to react. The serene beauty of a volcano can hide a silent threat, building up unseen right beneath our feet. The tragedy on that clear autumn day in 2014 wasn't just a random disaster, it was a lesson written in ash and rock. It taught us that some of nature's most beautiful creations demand our utmost respect, because they can erupt without warning, reminding us that we are only visitors on a planet that is still very much alive. Volcanoes remind us that Earth is alive, powerful, and unpredictable. The truth is, we may never know exactly when the next great eruption will come, but what we can do is stay informed, prepared, and connected. If you found this journey into the world's most dangerous volcanoes fascinating, make sure to hit the like button, share this video with others who love exploring Earth's mysteries, and subscribe to our channel for more deep dive documentaries. Because the more we understand our planet, the better chance we have of surviving its surprises. Until next time, stay curious, stay safe, and never stop exploring. And check out our next video on another one of Earth's incredible natural phenomena. Thanks for watching.